Okay, let's talk about section 2.1, functions and continuity. We're going to try and lay the groundwork here for chapter 2, where we'll be doing a lot of function analysis. All right, so let's start just by talking about relations. And a relation is just a formal relationship between two sets of numbers. All right, so they can be very concrete and attached to the real world, and they can be fairly abstract as well, and just numbers to numbers for no apparent reason based in reality, you might say. So let's start with the concrete one. So right here we have the months of the year and the low temperatures for some location. Okay, so this would be January, February, March on down, and then this is the low temperature in that month. Okay, so this is a relationship between time of the year and low temperature. That's all it is. It's a relation. All right, now what we're saying here in this one is that month one, January, had a low temp of 32. So what we can draw is we can draw arrows, if we want, from number to number here. This would be called a mapping. Okay, now this mapping is pretty simple because it just maps the month straight onto the low temperature, and we put it in a table because that's how we wanted to organize the data. And so it's not very interesting mapping. But we can set up mappings that are different, right? I mean, and they don't need to be like linear and perfect in a spreadsheet or in a table like that. Okay, so maybe we have like 1, 2, 3. All right, and this will be what we call the domain. Will usually be on the left. Okay, and in a function, when we talk about those a little bit later, the domain is usually the inputs, and then the range is the outputs of the function. But we'll get to that in a second. So these values over here, we're going to call the range. Okay, so where the domain maps to is called the range. All right, so let's put some numbers over here. Maybe we've got 20, maybe we've got 15, -10, and 11. Okay, and so maybe 1 maps to 20, and maybe 1 maps to 15 as well. And maybe 3 maps to -10, and maybe 2 maps to 11. Okay, I'm just sort of making these up. All right, but this is called a mapping, and the mapping has to do with you've got the domain, the inputs, you've got the range, the outputs, and the mapping piece is the arrows showing where those values go, which values go to which other values. Okay, so let's go talk about how this might apply to what we already know about graphs. I should say before we move on, you can think of the values on the left as like the x values, all right, and you think of the values on the right as like the y values. Okay. Okay, let's move on down here. And we will talk about functions, okay? Now, a function, the technical definition, is a relation, so what we were just talking about, in which each element of the domain is paired with exactly one element of the range, okay? So what I had up there previously, let's see if I can bring this back here. So what I had up there previously is was not a function because this element in the domain right here, 1, mapped onto 2 different values, okay? So that means that it was not a function. Now there's an easy way to remember this. It's called the vertical line test. Now you won't always have a graph, but you can always make a graph if you want to, all right? So the vertical line test says, your relation is a function if there's no place along the x-axis that you can draw a vertical line in which that line crosses more than one point. Okay, so let me show you what I mean. Let me give you an example of a function here. Okay, so maybe we got a point like this, a point here, a point here, a point here, and a point over here, right at the edge. Okay, so no matter where I draw a vertical line here, I'm not going to cross more than one point. Okay, now we could quickly break that if we wanted to. So as soon as I put a point, as soon as one x value maps to 2 different y values, so like maybe this maps to -1 and maybe it maps to 3. So we've got these 2 points here, and this x value maps to both of them. Therefore, it would not be a function because you can take a vertical line and it goes through both of those points. Okay. So that's what we mean by the vertical line test, and it's a quick way to figure out if a relation is a function or not. In that previous example that I showed you for a function, you could, if you had graphed it, you would have seen that you would have had 2 points stacked right on top of each other, okay? Now, there are different types of functions, a lot of different types of functions, okay? We're going to talk about one-to-one functions here, all right? Now, one-to-one functions will have more significance later on in the chapter, but for right now, we just want to talk about what they are and how we identify them, okay? A one-to-one function is a function in which each element in the domain is paired exactly to one unique element in the range, okay? So let me show you what that would look like, just real quick, and just a so in a mapping here. So let's put in here like 1, 2, 3, and then over here we'll have like 4, 5, 6. Okay, so each element in the domain, let's say, goes to one element in the range, like this. All right, so if we were to graph this out, you know, it'd be like, well, this isn't going to look very nice, but 1, 2, 3, and, you know, here, let's just say that's 4, 5, 6, and so you have like point, 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 okay? All right, and we could break this, though, if we had one element in the domain pair with an element in the range that's already been paired. So suppose that I plugged in like -1 into the domain, and then I paired that with 6. Okay, so over here at -1, I have 6 as the y. Now I have 2 different x values going to 1 y value. Therefore, it's not a one-to-one function. Now, one of my problems with like this type of functions, or types of functions like this in general, when we're talking about their characteristics, is that it's easy to get hung up in the words, right? And so I really like the vertical line test, checking if it's a function. I really like the horizontal line test to check if it's a one-to-one function. So for this, I can check and see if it's one-to-one by taking horizontal lines and sketching them, and same thing as the vertical line test. If it crosses more than 1 point, then it's not one-to-one. So right here, before I added that last coordinate there, whoops, there was no place where I could draw a horizontal line that would go through more than 1 point. But as soon as I put this other extra point here, all of a sudden now it fails the horizontal line test. Still a function, still passes the vertical line test, but it is no longer a one-to-one function, okay? All right, let's keep going here. Let's identify the domain and the range. Now, the domain and the range of a function, the domain and range of a relation is what I've already talked about. So the domain is the x values in the relation, and the range is the y values. If I give you a set of points, then you can quickly identify what the domain and range is just by listing out the x's and the y's. So the domain here, whoops, that's a line. Try again here. So the domain is going to be just taking the x values here. So -6, -5, -3. So -6, -5, -3. I should probably let's actually write this out nicer. Typically, you're going to write it like this. So the domain is equal to -6, -5, -3, -1, and 6. And then the range is all the y values. All right, so we have -1, -9, -7, 7, -9. Okay, now you want to quickly figure out if this is a function or not. The quickest way is just to look at the points and identify whether there's an x value that goes to 2 different y values. Then it would fail the vertical line test. Another way to do this, though, is just to plot the points. So you can plot -6, -1. So there's 1 point. -5, -9. So -5, -9 would be right here. -3, -7. So -3, -7 would be here. -1, 7. So -1, 7 would be up here. And then we'd have 6 and -9. So 6, -9. So this is a function, but it is not one-to-one. So let's write that down. It is a function. So yes, function. It is not one-to-one. Not 1 to 2, 1. Okay, it's not a one-to-one function. So that's I really like going to the graph to analyze these. Again, you don't have to, but I think it is pretty helpful most of the time. State the domain and range of the relation. Determine if it's a function. Determine if it's 1 to 1. Again, you should try this one. I'm going to speed through it here and explain it, but you should pause, give it a try, and then see how you do. Okay? All right, hopefully you paused and you're coming back now. So the domain of this is all the x values. So it's going to be 2, -1, -2, -1, and 2. And actually, you don't need to write, you don't need to write duplicates. Okay, and honestly, you should, good job, Cresswell, you should write them in numerical order too. So we've got -1, -2, -1, and 2. Okay, I'm not going to be super picky about that, but probably should do it that way. Okay, so then the range is going to be all the y values. The y values go from -2 to 2. So -2, -1, 0, 1, and 2. Okay, then the question is it a function or not? Well, let's plot the points. 2, -2. So there's a point right here. We've got -1, -1 here. -2, 0. Oops, sorry. -2, 0. So that's here. And I've got, let's see, -1, 1. And 2, 2. So 2, 2. Okay, so it's not a function. And it is, yeah, it is not a function, and it is not 1 to 1 because it's not a function. So it can't be if it's not a function, it can't be a 1 to 1 function. Okay.